So in this section of the tutorial, we're going to be using a number of tools and libraries. And one of the ones we're going to use is the Boost library. It contains some features and capabilities that we're going to take advantage of. Most Linux systems have Boost installed as header files, and you can't use those because some of the features we're going to use require the compiled version of Boost. The sections that have libraries with them that need to be linked. So you can go here to the Boost user manual, and there's complete installation instructions, how to download it. You'll want to download an appropriate version, and I'll show you that, but you can follow these instructions and run through their little tutorial to make sure everything works on it. So that's Boost. Where you want to download Boost, we'll go here. Just go to Google, download Boost. And I'm using, I actually have installed version 1.73, but you can use any later version. I doubt that anything that we're doing will change. You just want to download the appropriate file here and then follow those installation instructions here. Oops, here. Follow these installation instructions and everything should work fine. The next thing that we're going to do use is LLVM. So here's the LLVM compiler infrastructure project. LLVM is a tool that we're going to use to build our actual final code. We're going to use it to generate code. And so you can go into here, and there's a download section you'll see here. You can download LLVM and Clang and so forth. You'll need to install these. You'll need to follow these instructions. I'm not going to walk through all this process. It's a fairly long process. I'm sure if you're learning about compiler design, you can install software. So be sure to install both Boost and LLVM with Clang. And I'm going to go through how to set up the CMake files and stuff to use all of these tools properly. All right, this is just a quick overview of the compilation process and how that process is going to work within our situation and what we're going to use, the tools that we're going to use, and so forth. So the compilation process begins with an input file. This input file contains our source code. We will, our process will open up that file or a group of files that are to be compiled and send them into the Lexical Analyzer to start the compilation process. The Lexical Analyzer, if you recall from the previous videos, it breaks down the incoming stream of characters into tokens. Those tokens can represent words or symbols or whatever it may be, and those tokens form up a stream that goes into the parser. The parser then gathers those tokens together and tries to match them up in a production and actually generate something from it. And what does it generate? Well, it generates the abstract syntax tree, which is a group of objects chained together and linked together that form up a representation of our program. The AST can then be put through an optimizer. In our case, we'll be using LLVM as the optimizer. And we'll also be using LLVM to generate code. And I'll show you how all that process works, and we'll use the abstract syntax tree to generate that code and perform those optimizations. And I'll explain the various choices you have for optimization, but the code generation then produces bytecode, and that bytecode can be executed right there on the system immediately using LLVM tools, or we can run it on a JIT compiler, or we can cross-compile it to different platforms, however we see fit. So that's generally how the overall process works. We're going to be using Flex rather, and Bison, the GNU tools for our lexical analyzer and parser, and then all the rest of this, and that'll generate our AST, and all the rest of this on the bottom side is LLVM. And we're going to set that up within our code to use the LLVM tools to do that. So thanks for watching, and we'll move on to building it up a little piece at a time. This is going to be a little bit more complex than the previous ones, but we'll get there. Thanks for watching.